Assessment number 1. We are asked to A. Draw the small signal equivalent circuit, B. Determine RE, C. Calculate base voltage and collector voltage, and letter D. Determine input impedance and AV equals to VO over VI. Letter A. Draw the small signal equivalent circuit. Small signal model is an AC equivalent circuit. The nonlinear circuit elements are replaced by linear elements. Assume that all DC sources are turned off. Remove all blocking capacitors and replace with short circuits. Redraw the given circuit diagram into small signal model. So as we can see, the given circuit diagram is transformed into linear or arranged in straight line. So here is the input impedance. R1 and R2 are in parallel. BRE is in short circuit, flowing towards the current source, which is the BIB. RO and RC are in parallel also. So for RTH, we have R1 parallel to R2. So 220 k ohm times 56 k ohm over 220 k ohm plus 56 k ohm. So RTH is equals to 44.64 k ohm. For VTH, we have VCC times R2 over R1 plus R2. 20 volts times 56 k ohm over 220 k ohm plus 56 k ohm. So the value for VTH is 4.058 volts. For IB, we have VTH minus VBE over RTH plus beta plus 1 times RE. So we have 4.058 volts minus 0.7 volts, which is the constant for VBE, over 44.64 k ohm plus 180, which is the value for beta plus 1 times 2.20 times 2.2 k ohm. So the value for IB is 7.58 microamperes. And for IE, we have beta plus 1 times IB, so 180 plus 1 times 7.58 times 10 to the power of negative 6 amps. So we have 1.372 milliamps. So after getting the value for RTH, VTH, IB, and IE, we can now determine the value of RE. So we have 26 MV over 1.372 MA. So the value for RE is 18.95 ohms. That means that the value we get for RE and the expected answers are same for letter C. So in order to calculate base voltage and collector voltage, we need to solve first for IC and VE, or the collector current and emitter voltage. So in getting the value for IC, we have beta times IB, 180 times 7.58 microamps. So the value for IC is 1.364 milliamps. For VE, we have IE times RE, 1.372 times 10 to the power of negative 3 times 22 times 10 to the power of 3. So the value for VE is 3.02 volts. Since we already have the value for VE, we can now solve for VB. So VB is equals to 3.02 volts plus 0.7 volts, which is the constant for VBE. So the value for VB is 3.72 volts. We already have the value for IC, which is needed to solve for the VC. We have here 20 minus 1.364 times 10 to the power of negative 3 amperes times 4.7 times 10 to the power of 3 ohms. So the value for VC is 13.59 volts. So it means that the value for base voltage and collector voltage that we have is the same with the expected answers that are given, which is 3.72 volts and 13.59 volts. For letter D, we will solve for the value of input impedance is equals to RTH parallel to R beta times RE. So we have 44.64 k ohm times 180 times 18.95 ohms over 44.64 k ohm plus 180 times 18.95 ohms. The value for input impedance is 3.17 k ohm. To get the value for AV, we'll use the formula negative RC parallel to RO over RE. So we have negative 4.7 K parallel to 1 over 30 microseconds, which is the value for 1 over Gauss, over 18.95. So we have 4.7 K times 1 over 3 times 10 to the power of negative 6 over 4.7 K plus 1 over 30 times 10 to the power of negative 6 divided by the value for RE, which is 18.95. So the value for AV that we have is negative 217.37. It means that the value for input impedance that we have, which is 3.17 k ohms, is the same with the expected answer, while the value that we have for AV is different.